Section 2, Video 2. Let's look at some shortcuts or specific formulas for specific shapes. Here we have a rectangular prism with dimensions laid out where this is width, length, and height. And they tell you that you would take 2 times length times width plus 2 times length times height plus 2 times width times height. That's what I just referenced right here. Now, what they're doing is they know that the front face and the back face are congruent and parallel. The left and the right face are congruent and parallel, and the top and the bottom faces are congruent and parallel. So basically they're saying find the area of one of them and take it times 2, find the area of another one and take it times 2, and find the area of the third pair and take it times 2. A cube, if you notice, means it is squares on all faces, a perfect cube, so all the faces are squares, therefore all the sides are the same length. So in other words, all the edges. So there are 6 squares on a rectangular prism, in this case a square prism. So each one is s squared, and there are 6 of them, so they take it times 6. So again, a shortcut way to find the surface area of those shapes. So let's put these to the test. Okay, here we have a rectangular prism. Find the surface area. So as we said, the specific formula for surface area of a rectangular prism is 2 times length times width plus 2 times length times height plus 2 times width times height. So if we look at this shape, we have height is the 12. We would call 4 the width and 3 the length. So above then, to do this calculation, we would do 2 times length, which is 3, width, which is 4, plus 2 times length, which is 3, times height, which is 12, and then plus 2 times width, which is 4, and 12, which is height. So they're basically finding the area of each face and taking it times 2. Or one of the 2 matching faces. I take that back. Sorry about that. And if we do that calculation, we should get 192 centimeters squared because we have units. Now, just for argument's sake, I'm going to also do this doing the general formula, which is 2 times b plus p times h. Now, b represents the area of the base. Now, in this case, the base would be this shape right here, this rectangle, and that area would be 4 times 3, so 12. So it's 2 times the area of the base, which we found to be 12. It is the plus the perimeter of that base. So if you look at the lengths, the back side would be 3 and the left side would be 4 because it's a rectangle. So the perimeter would be 4 plus 3 plus 4 plus 3, which is 14. And we take that times the height, which is 12. And that calculation would also give you 192 centimeters squared. So 2 different methods for that one. It's up to you to decide what you feel would be best. Okay, now we have a word problem. It tells us that we have a birthday gift that's in a box of 55 centimeters long, 40 centimeters wide, and 5 centimeters high. So it's a box with dimensions of 55 long, 40 wide. Sometimes writing a picture helps. Oops, sorry about that, wrong color. 40 wide, and then 5 high. They have a sheet of paper they want to use to wrap it, but it's only 75 by 100. Long sheet of paper to wrap it. The question is that enough paper to cover that box? Well, the area of this wrapping paper would be found by taking 75 times 100, which is 7,500 centimeters squared. And the question is that enough to cover the surface area of this shape? So we would find the surface area as we did before. And it's up to you which choice you take, but I'm just going to go ahead and use the specific one to this shape, which is 2 times, and again we follow our formula, 55 times 40 plus 2 times 55 times 5 plus 2 times 40 times 5. That calculation would give us 5,350 centimeters squared. So the question says, is this enough paper to wrap this much area? And the answer is yes.